Hi, my name is Josh Jackman, and it's a pleasure to introduce you to my research group, the Translational Nanobioscience Lab. Our group explores cutting-edge topics at the interface of nanobiotechnology and translational science. Examples include antiviral technologies to stop viruses, biosensors for pharmaceutical drug development, antiviral, antibacterial, anti-inflammatory, anti-cancer drugs, as well as lipid membrane biophysics. We have a very strong focus on global team building and innovation. So currently, my lab has 3 postdoctoral fellows and 6 graduate students, plus interns from around the world. So we're a very diverse group. We have active participation in international education and research programs. For example, I currently have 2 students in my group who are participating in the SKKU NTU dual PhD program. And we have a lot of cooperation and research collaboration activities with universities and companies in the US, Europe, Korea, and Singapore. Some examples of research that we've completed in the past few years, including antiviral peptides to stop viruses. This was featured in Nature Materials and has led to a new class of antiviral drugs to stop Zika virus, dengue virus, and now the virus that causes COVID-19. And we're doing a lot of this work together with government agencies in the US and Europe, including Public Health England, the US Army, and the NIH. This research on antiviral technologies and the antiviral peptides was recently featured by Nature on the homepage of Nature and in a feature article highlighting next generation antiviral strategies. So there's a lot of potential for these kind of new peptide technologies to solve really big global health problems now and in the future. We also have a strong focus on biosensors for drug development. So this is some pictures of different types of nanoplasmonic optical biosensors. And we also work with acoustic biosensors and different type of micro-patterned platforms. We also have a lot of research in lipid nanotechnology to create lipid bilayer coatings that can be very useful for diagnostics and biosensors, and also membrane engineering to study how viruses and exosomes work and how we can stop them and also utilize them sometimes for therapeutic applications. And there's a lot of research. I could talk an hour about research, but fundamentally, the group success, research success, it equals student success. So, when you're listening to this video, one thing I want to kind of communicate is, what can you learn in our lab? And my philosophy about how I can help students is divided into 2 areas. The first is research training. So, in our lab, students learn how to design, conduct, and analyze research. It's not enough to just do the experiment. Learning how to design a scientific experiment, asking an important question, doing the experiment, and then actually analyzing the data and really thinking about what does this data mean and what is the significance. Cross-disciplinary teamwork and industry collaboration is another big focus of our lab, especially the teamwork environment and really building an international research environment. So working with people from different backgrounds, different cultures, different disciplines, how can we make a team to solve the problem? For professional development, this is a very important part of students working in my lab. Every student has a different objective. Some students want to go on to get a PhD, postdoc, hopefully a research career such as professor or government scientist. Other students want to get maybe an industry job. Everyone has a different goal. My job is to help you define your goal and help you achieve your goal. So my job, how I can help you. And there's also chances for industry and international internship options when working in my lab, and also a strong emphasis on global communication skills. We have people from a lot of different backgrounds. So this is not only about Korean and English language, but global communication skills. I mean, how can you work with people from different backgrounds, work together to find solutions, and build successful solutions to research problems. So thank you for listening to my talk, and hopefully this introduction to the Translational Nanobioscience Lab was useful. I have the link to our current website here, and if you have any questions, please feel free to contact me anytime at my email address. You can either ask me questions directly, or I can also introduce you to students in my lab. And we're always eager to welcome new and passionate students. So please feel free to contact me, and my door is always open. Thank you very much.